Hello. Today's video lecture will consist of section 1.4 and it is dealing with differentiating polynomials, and this is a very easy section. You are familiar with almost everything which we are going to discuss here. So to start off, when we are differentiating polynomials, we will use the power rule, sum rule and constant multiple rule of differentiation. Suppose if we have a polynomial f of x is equal to 3x raised to 5 minus 8x raised to 4 plus 4x plus 2. Okay, so this polynomial can be treated as the sum of four terms, which are the first term being 3x raised to 5, the second term being minus 8x raised to 4, the third term being 4x, and the fourth term being 2. So summing all these terms, you get the polynomial f of x. So each of these terms are called monomials. Monomial is a product of a constant and a power of x. So see, you can see 3 is a constant and x raised to 5 is a power of x. So 3 into x raised to 5 is a monomial. Similarly, minus 8 into x raised to 4, 4x, 2. All of them are monomials. Here 2 will be equal to 2 into x raised to 0. Right. 2 is equal to 2 into x raised to 0. So that is also a monomial. So basically when we are differentiating polynomials, we just have to think that the polynomial is actually a sum of monomials. Then you do the corresponding differentiation uh, which will imply the use of power rule, sum rule and constant multiple rule of differentiation. So let's see how we can do all these things. Earlier, while we were discussing in the earlier section, we had seen that for n is equal to 1, 2, 3 or n is equal to minus 1 or 1 by 2 or anything, we can say that d by dx of x raised to n is equal to n into x raised to n minus 1. So here we can prove it generally, to establish this rule generally for any positive integer n by using limits. So suppose if f of x is equal to x raised to n. So first we have to compute f dash of x, that is our aim. That is, we have to find the f dash of x is nothing but limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, right? So let's calculate f of x. We know that f of x is equal to x raised to n. So here we are calculating, there's a mistake there, printing mistake. So here we are going to calculate f of x plus delta x. So when we calculate, you get x plus delta x the whole raised to n is equal to x plus delta x into x plus delta x plus etc. x plus delta x n times, right? So we have to know what is the expansion of this product. So for that, suppose you take two of them. Suppose if it is two among them, x plus delta x into x plus delta x. So you get x square plus x delta x plus delta x into x plus delta x the whole square. That is nothing but x square plus 2x into delta x plus delta x the whole square. And if you're taking the three of them and its product, that is x plus delta x into x plus delta x into x plus delta x. So when you open the braces, you have the term sitting here and you simplify them to obtain x cube that is equal to the simplification you will get x cube plus 3x square into delta x plus 3x into delta x the whole square plus delta x the whole raised to 3. So generally we have to find x plus delta x the whole raised to n. So you can see that when you expand, generally here you have for 3 you have x cube plus 3 x square into delta x, that is the second term. And for when we had the product of 2 among them, you had x square plus 2x into delta x. The first and the second term were like that. So if you are taking x plus delta x whole raised to n, the first term will be, first monomial will be x raised to n, plus the second one will be n into x raised to n minus 1 into delta x. Okay, plus lot of terms, and all those terms will have terms involving delta x whole square, delta x whole cube, plus comma etc. comma delta x whole raised to n. That is going like that. Okay. Now we are considering f of x plus delta x minus f of x divided by delta x. That is x plus delta x whole raised to n minus x raised to n divided by delta x. So when you expand this, you said that you have this, and when you subtract x raised to n from that, so you get from here. So that means in the numerator you have n into x raised to n minus 1 into delta x plus terms involving delta x square plus comma etc. delta x whole raised to n, the whole divided by delta x. So when you divide by delta x, the first term will simplify to n into x raised to n minus 1, and the rest of them will definitely have terms which involve delta x and etc. delta x raised to n minus 1. So in the inside the braces, when you add them up, that will be a polynomial in the variable delta x, right? So when delta x is tended to 0, the all the terms here sitting inside the braces will tend to 0, because that polynomial is 0. So in the left hand side, when you apply limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x is nothing but f dash of x. So that will become nothing but n into x raised to n. So here we proved the power rule, which is if we have a power x raised to n and we are asked to differentiate, uh, then you have if f of x is equal to x raised to n, you have f dash of x is equal to n into x raised to n minus 1. So any n is equal to 1 to etc. Going like that. Example 1, we are asked to compute derivatives of x raised to 8, x raised to 12 and x raised to 99. So you have to simply apply the power rule. So you'll have n here as 8. So d by dx of x raised to 8 is equal to 8 x raised to 7. Similarly, d by dx of x raised to 12 is equal to 12 x raised to 12 minus 1, which is 11. D by dx of x raised to 99 is equal to 99 x raised to 99 minus 1. So you have 98 here. So now you are going to see what is constant multiple rule. Constant multiple rule says that if we have a function f of x and k is any constant, the and suppose you have the derivative of f of x to be f dash of x, then kf, the function kf, the whole dash x is equal to k into f dash of x, or it is nothing but d by dx of k into f of x is equal to k into d by dx of f of x. So to prove that, suppose assume that h of x is a new function which is equal to k into f of x. Suppose its derivative is existing. So we know that h dash of x is equal to, by definition, limit delta x tends to 0, h of x plus delta x minus h of x divided by delta x, which is equal to limit delta x tends to 0, k into f of x plus delta x minus k into f of x divided by delta x, which is equal to limit delta x tends to 0. You can think of k as one term into the second term will be f of x plus delta x minus f of x divided by delta x. By the properties of limits, you know that limit of a b is equal to limit of a into limit of b. Use that property here. So you have limit of delta x tends to 0 k into limit of delta x tends to 0 f of x plus delta x minus f of x divided by delta x. And you know limit of a constant will be k, the constant itself, and since f dash exists, this limit is nothing but f dash of x. So in total you have obtained h dash of x is nothing but yes, h dash of x is nothing but uh, h dash of x is nothing but d by dx of k into f of x, and we obtained that is equal to k into d by dx of f of x. So we are done. We proved it. Now differentiate the monomial sitting here. First one is minus 3 into x raised to 7. D by dx of minus 3 into x raised to 7 is equal to minus 3 into d by dx of x raised to 7 by the constant multiple rule, that is equal to minus 3 into 7 x raised to 7 minus 1. So in total you get minus 21 x raised to 6. Now 5 into root x, we have to find the derivative d by dx of 5 into root x is equal to 5 into d by dx of root x, and we know that d by dx of root x is equal to 1 by 2 root x. We have proved it in earlier section 1.3. Similarly, d by dx of 1 by x is equal to 1 by minus 1 by x square, we have proved in earlier section. So d by dx of 8 by x is asked. So you have that is equal to minus 8 by x square, and d you have minus 6 into a x square. So when we are finding the derivative, you get minus 6a into d by dx of x square, which is minus 12 into ax. So that was the application of constant multiple rule. The next is the technique which is called sum rule. So if you have two functions f and g, the sum of f plus g is given by f plus g of x is equal to f of x plus g of x. So that is an important part you have to remember. Okay, so just remember that. So that is nothing but suppose if you have functions f here. So for each point here you have a function here. For any point here you have the corresponding function here for this f, and so on. And likewise you have a g here. Okay. So you have to find f plus g at each point. So suppose I am taking 1. So its corresponding f value will be here and the g value will be here. So suppose it is 2, f of 1 is equal to 2, and here g of 1 is equal to 1. So f plus g of 1 will be 2 plus 1, which is equal to 3. Here f plus g of 1 is defined as f of 1 plus g of 1. F of 1 here will be 2, g of 1 here will be 1. So you have 2 plus 1 is equal to 3. Similarly for 2 here, f of 2, f plus g of 2 is equal to f of 2 plus g of 2. So f of 2 here will be 2.5, say that is 2.5. So we have that is equal to 2.5 plus g of 2 is nothing but 2. So you have that is equal to 4.5. So this will be the corresponding point, 4.5. Okay. Now consider 3. 3 you have f plus g of 3, that is equal to f of 3 plus g of 3. So what is f of 3? F of 3 is the point here, let it be 3. So you have that is equal to 3 plus what is g of 3? G of 3 is nothing but here the g of 2 was 1, right? So yeah, because it is a constant function 1. So that is 3.5. Okay. Similarly here g of 3 is nothing but 1. So you get 3 plus 1 is equal to 4. So here Yes, that is 3.5. Okay, so this is 3.5 and then 3 will have correspondingly the point 4. So we can draw the graph of f plus g here along those points. So we get the new function. This will be f plus g. So that's what the sum rule says. Now consider the example 3 where f of x is given to be 3x square plus 5x plus 9 and g of x is equal to 2x square plus 5x. So you have to uh, verify whether f plus g, the derivative of f plus g is equal to derivative of f plus derivative of g. Okay, so you know that if f of x is this, f dash of x will be 6x plus 5. If g of x is this, g dash of x will be 4x plus 5. So you have f dash of x plus g dash of x is equal to, when you add them up, you have 6x plus 4x, that will be 10x, then 5 plus 5, you have 10x plus 10. And then also f of x plus g of x, when you add the polynomials together, you get uh, 5x square plus 10x plus 9. So find the derivative of both this function, that is d by dx of f of x plus g of x. So you have f plus g the whole dash of x is equal to, derivative of this will be 10x plus 10. So that is equal to f dash of x plus g dash of x. So this one is verified for this example. So we have to prove this in general. So generally the sum rule here says that to differentiate f plus g, you just have to find f dash plus g dash, or it can be written in any three ways. Okay, or d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. You have to prove this. So whenever you have a mathematical statement, see here we have the mathematical statement for sum rule to be this. So we proved the same or verified the same for the example sitting here. We verified the statement is true for an example. Then you have to have a mathematical proof for that uh, statement. And then you can have some application or diagram which make the result true. So that's how we are convinced that a mathematical statement is true. So we are going to do the proof part. So suppose if f plus g the whole dash at a point x naught. Let this is an arbitrary point x naught. It can be anything. Suppose if the limit exists at that point, so you can by the definition of f plus by the definition of differentiation, you know that f plus g the whole dash of x naught is nothing but limit delta x tends to, that is equal to limit delta x tends to 0 f plus g of x naught plus delta x minus f plus g of x naught divided by delta x, and just rewrite the function. We know that this is equal to f of x naught plus delta x plus g of x naught plus delta x. Similarly here we have f of x minus of f of x naught plus g of x naught. So the minus will be for both of them, and you have the numerator to be this. Then make it into two fractions like this possible, and then apply the limits. So applying the limits, you have limit delta x tends to 0 the first term plus limit delta x tends to 0 the second term. Now when we know that f is differentiable at x naught and g is differentiable at x naught, this will be equal to f dash of x naught plus g dash of x naught. And earlier here we have that is f plus g the whole dash of x naught. So we proved the sum rule here. and also we can extend it to three functions. If f of x plus g of x plus h of x is given, we have d by dx of f of x plus g of x plus h of x will be equal to d by dx of f of x plus d by dx of g of x plus d by dx of h of x, by taking it as two terms. See, first you can take f of x plus the term here, apply the earlier result, that is equal to d by dx of f of x plus d by dx of the term sitting here, and this term we can again apply the sum rule to obtain the final uh, term sitting here. Okay, find the formula of the derivative 8 f of x minus 10 g of x. So here the solution says that if d by dx of 8 into f of x minus 10 into g of x, that is equal to d by dx of 8 into f of x plus d by dx of minus 10 into g of x. So you get 8 into d by dx of f of x minus 10 into d by dx of g of x. Simple. That's how you differentiate the polynomial given. Example 5 gives two polynomials. Just find the derivative. D by dx of x raised to 95 plus x raised to 23 plus 2 into x square plus 4x plus 1. Applying the sum rule, you get like this, and finally you get 95x raised to 94 plus 23x raised to 22 plus 4x plus 4. And for B, you have d by dx of 4x raised to 9 minus 6x raised to 5 plus 3x is equal to 36x raised to 8 minus 30x raised to 4 plus 3. So in general, if we have a derivative uh, to be found out of a polynomial, suppose the polynomial is c n x raised to n plus etc plus c 2x raised to 2 plus c1 x plus c naught, then d by dx of f of x is equal to, generally, the definition of the derivative of the polynomial will be the one sitting here. N into the constant. So this is nothing but a constant. So this is nothing but if f of x is equal to, we use constants like a and, right? So don't misunderstand this for the permutation and combination, that combination C. This is nothing but a constant. Cn minus 1 is a constant, C2 is a constant, C1 is a constant, like that. So example 6, find the derivative of x cubed plus 5x square minus 9x plus 2. That will be, the derivative of that will be 3x square plus 10x minus 9. Similarly, you can find example 7. The first one, derivative of f of x is given as the product of two terms. You just expand the terms and then find the derivative. F dash of s will be, when you expand, you get the term to be this, the polynomial to be this in s, and find d by ds of f of s is equal to f dash of s, which is equal to 5s raised to 4 plus 15s square plus 2s plus 6. Similarly, if the polynomial is 10x cubed minus 8x plus 5 root x, find the derivative, that is equal to d by dx of 10x cubed plus d by dx of minus 8 by x plus d by dx of 5 into root x. Then finding the derivative, you get 30x square plus 8x square, because there is already a minus, and when you take the derivative of 1 by x, you have minus 1 by x, so you get a positive sign here, plus root of x will have derivative 1 by 2 root x, so there is a 5 by 2 here, and 1 by root x, that is nothing but x raised to 1 by minus 1 by 2, or it can be restructured to be written as 30x square plus 8 by x square plus 5 by 2 root x. Now find the slope of the tangent line to the graph. So this is nothing but, the question is Suppose if our function is something like this. So we have to find the tangent line, the slope of the tangent line. So the tangent line will be the line which touches the curve only at this point. Okay, if this point is x naught, this will be the tangent line at x naught, tangent line of the function f at x naught. And to find the slope, you just have to find the derivative of the corresponding tangent line, corresponding function. So if the function is y is equal to x raised to 4 minus 2x cube plus 1, in order to find the slope of the tangent, you have to find the slope of the function at x is equal to 1. So you have y is a function, x raised to 4 minus 2x cube plus 1. So find dy by dx. You get 4x cube minus 6x squared. Substitute for x is equal to 1. So you get, that is, dy by dx at x is equal to 1 will be equal to 4 into 1 cube minus 6 into 1 square. So you get 4 minus 6 is equal to minus 2. Similarly, to find the velocity, for the second question, you have the train and you have the position x, which is in terms of time. So to find the velocity, you just have to take the derivative of the x with respect to t, dx by dt. So you get 6t minus 1 by 2 root t. So then you have to find at t is equal to 2. So dx by dt at t is equal to 2, you get the value to be finally simplified as 48 minus root 2 by 4. So you can read along the supplement of the physical model given and understand how the sum rule and all the things we discussed are coming into that picture. Also solve exercises here 6, 8, 11, 12, then 41, 42, 43, 44, 45, 46. So that's all for today's lecture. See you in the next video lecture. Thank you for watching.